Hello everybody, my name is Javed Malik. I belong to Department of Earth Science at IIT Kanpur, and my specialization is paleoseismology and paleo-tsunamis. So basically I look for the signatures of ancient earthquakes and ancient tsunamis preserved in the sediments and preserved on the landforms, and mostly our research work is along Himalayas and in Andaman Nicobar and Kutch region. So mostly I deal with the hazard. Now this course which I am offering, I am extremely happy to offer this course because most of the time we ignore most of the earth processes which are taking place around us. Okay, and this course is extremely important for the civil engineers in particular, because we keep on doing a lot of construction, and as we know that during this in couple of years or maybe in past 1 decade, we have boom of construction which is going on, and we are not very much concerned about the hazards or the earth processes which are taking place around us. So every day if you move on this earth surface, lot many processes are taking place, and we should be aware of that. Okay, and in particularly for civil engineers it is most important, because we are coming up with lot many townships, bridges, roads and all that, and we need to understand that what type of constructions we are doing, what is the foundations on which we are putting the structures, and what will be the hazard which will be associated with the plate motions or any other related features on the earth surface. And so mostly what we can do is, we can, of course, if we talk about the hazard, we can minimize the hazard understanding it, and of course when we are coming up with some major townships or so we need to know the land use pattern and all that. Okay, and the construction material. So this is a picture of tsunami which is from Japan, and which talks about that how tsunami can affect the day-to-day life in any region. Okay, particularly in the coastal regions and all that. Okay, so now what we basically will try to do, that let us have an attempt to understand the dynamic earth and understand the processes which are occurring around us. Okay, so I believe that you might be having the course content with you people, but we will start slowly and then try to understand point by point, and go into the greater detail when we are talking about the individual aspect of geosciences or earth sciences. Okay, so this particular lecture, the first lecture, will talk about the importance of geosciences in civil engineering and as a whole, and then we'll get on to the plate tectonics, where we are going to talk about the rock cycles, how the rock cycles and the plate tectonic is linked, how the rocks are formed and all that. Okay, and during the discussing about the plate tectonics, we'll talk about the continental drift, sea floor spreading, and type of plate motions and all that. Okay, and different type of plates like continental plates and oceanic plates and all that. And then we will talk about the different type of rocks, but before moving to the different type of rocks, we will discuss about that what is minerals and what are the different type of minerals, how they are formed, at what temperature they melt, what is the importance of magma flow and all that. Okay, we'll talk about that. Okay, and then coming to the rocks, as it is known that we have different type of rocks and which are produced at different locations. Okay, like igneous rocks, they are related to volcanic eruptions and volcanic intrusions, and then we are having sedimentary rocks, we are having metamorphic rocks. Sedimentary rocks are the rocks which are formed from the eroded material or the sediments when they get compacted or solidify, and the metamorphic rocks usually are seen which are metamorphosed, or the material which is metamorphosed at the greater depth of the earth interior under great pressure and temperature. So, we will try to look at the properties of these rocks, and then when we are talking about the minerals, then we will be able to talk about that how the different minerals are important in terms of their hardness and all that. Okay. So, this also will help us in understanding the different type of rocks, because as a civil engineers you need to know that what type of material you are using for the construction part. Okay. And what are the materials which are available in the near source, near the construction areas. Okay. So, that is also important as part of the resource. Then we will talk about the plate tectonics implication towards landscape change and hazards and risk. Okay. Now, plate motions have resulted into a drastic sculpturing of the landscape over the time, and one of the best example what we see in the Indian subcontinent is the Himalayan formation of the Himalaya. Himalaya was formed because of the plate motions. Okay. When the Indian plate collided with the Eurasian plate, that also we will talk when we are discussing about the plate motions and plate tectonics. Then this particular, there is a geological structures. This is extremely important when we are trying to put any civil structures in any particular area. Okay. And this all features like fold, faults, joints, unconformities are seen in most of the rocks, because the plate is under compression or plate is under like tectonic forces are deforming the plate. So, we will be able to see this type of geological structures at most of the places. Okay. And we need to know, because this geological features will affect the strength of the material. Okay. So, it can reduce the strength of the material, and it can result into the devastation if we are putting any structure without knowing it on the earth surface. So, this is extremely important, and to avoid the major disaster, we need to understand this geological structure. So, we will talk about that, and then of course, we will talk about the seismology of earthquakes, where we will talk about the what is magnitude, what is intensity, how when magnitude scale was developed, and what if we study the intensity, how it helps and all that. Okay. So, basically the intensity were been used in the like earlier period when the magnitude scale was not developed or the equipment was not developed, there is a seismograph, but now we have the seismometers which can measure the energy released during an earthquake, and we can have the magnitude in no time actually. And then related seismic hazard related to earthquakes, I will talk in terms of particularly in terms of Indian subcontinent, and then earthquake predictions, we will talk about that. Okay. Of course, we cannot predict very precisely, but yes, of course, we can have the understanding that when the next earthquake will occur and in which particular area, so and along which zone, so that at least we can minimize the hazard and risk in that part. Okay. So, we can save people, but we cannot rule out the possibility of the occurrence of the earthquakes in any particular region. Then coming to the mass bursting, as we have been hearing that during the monsoon season we have a lot of landslides, we have in the hilly areas, and of course, the subsidence is related to the subsolution activities subsurface, but the landslides are mostly seen on the surface in the hilly regions during the monsoon season. Again, this all deals with the material, what type of material are there along the slope. And then of course, we will talk about the surface processes, and in this course we will be talking more about the river or river landforms related to river or the fluvial landforms, and it's what are the importance of that and how they are formed. Okay. And how to identify them actually, that is also important for us actually. Then we are going to talk about the environmental geology and criteria for site selection. Okay. So, in environmental geology we will talk a little bit about that how the waste disposal, okay, in any region affects the groundwater or maybe the nearby environment. Okay. And the criteria for site selection, of course, is very much important Here we have given only two points here, like structures like dams and tunnels. This is in particularly in hilly areas, okay, but we can also apply this elsewhere. When you know about the rocks, you know about the soil, you know about the landscape and all that, you can apply all that knowledge while selecting the site for any particular region. Okay, this one, these are the textbooks. I am not very sure that this will be available, but most of the slides which I am going to talk, okay, or teach will be available to you people, but these are some books which you can refer, okay, for the basic earth sciences. Okay. So let us move ahead. So first look at the planet. If we look at the earth as a complete system, what we see is, this is a very good story which is mostly available in many of the textbooks, okay, which talks about that how the solar system evolved, okay, over the time, and then what exactly happened. So if you look at this one, you can look from here, okay. So we are having, this was the first event which talks about that around 12 to 13 billion years ago there was a big bang, okay. So this was like a giant explosion, okay, which resulted into the formation of galaxies and all that, okay. So this was the one event which we call the Big Bang event, which occurred at around 12 to 15 billion years ago, and this explosion produced atomic particles that later formed galaxies, stars and planets, okay. Later there was another one which was at around 6 to 7 billion years ago, okay, and that was, which was very much similar and known as supernova. And then finally the earth came in, that is the solar system came in, okay, at around 4.6 billion years ago. Now this is the time when the thing started in the earth, and if you look at the whole this spiral picture, it talks about the various eras, then it talks about the epochs, and then it talks about the period, okay. So these are the different time frame, what we call the geological time scale, okay, which has an era, then you are having the epoch, and then you are having the period, okay. So right now we are in the Holocene epoch, which is almost like 10,000 years old, okay. But now probably because of the more the added effects by the humans, okay, we will be having another epoch which probably will be named as Anthropocene, okay. So it starts with almost like 4.6 billion years back, what happened, and slowly get into the era, that what we call the Precambrians, then we are getting into the Paleozoics, okay, and then we are having the Cenozoic part, okay, and then one is the Mesozoic one, okay. So this one is the most well known because of the extinction which happened here during the Jurassic period, okay. So this is the period what we are talking about, the extinction of the dinosaurs and all that. So many events occurred during this overall period right up to the Cenozoic era, okay, and that's how the earth evolved. And this is the last is the phase, that is what we see. This is the time when the industrialization came in actually, okay. So this is the Holocene epoch is the most important one, and mostly we try to, if you would have to try to understand the hazard part, we mostly take the Holocene epoch for understanding the hazard and all that. Nevertheless, for the rocks and all that, we cannot leave any part of this, okay. We need to have the understanding of all this, okay, because different rocks formed, and the rocks are older and younger, okay. Still we are having the younger rocks which are almost couple of 100 years old, okay, and then if you go back, maybe you are having the rocks which are as old as 290 million years old, okay. Now, if we are talking about the Earth, then no other planet in the solar system currently has the right chemical and physical mix, okay, which is needed to support the life. Okay. And until now, no conclusive evidence of the life exists elsewhere in the universe. Okay. So, in that sense, Earth is a unique planet amongst the solar system. Now, just broadly, very quickly, we will look at, okay, and that what we are having. Okay, we are having the solar system, and then we are having Mercury, Venus, Earth, Mars, Jupiter, Saturn, and then we are having Uranus, Neptune, and Pluto. Of course, this Pluto is gone now. Okay, so we have the planets here, terrestrial planets, which are been classified as, and then we are having rest, which are the giants, and gaseous planets. We are having this are the Jovian planets. Okay, so terrestrial planets are rocky planets, and which are closer to the sun. Another one is the Jovian planets. Of course, I understand that you people know, but let us move slowly and get into the domain of our sciences. Okay. So, the planet, if you look at, okay, the solar system, 8 planets can be divided into the terrestrial. This we have already talked about. So, I will just move ahead, and then we are having couple of around 4 is you are having the Jupiter, Saturn, Uranus, and a Jovian planet. Okay. And they are the farthest and much larger as compared to the terrestrial planets. Okay. And comparatively less denser, as we see here, they are much denser as compared to this one. Okay. Now, some facts which we all see and we all understand about the Earth. Okay. So, age of the Earth is around, so this you should try to remember, that the age of the Earth is around 4.5 to 4.6 billion years ago, and this age was determined from the radiometric dating of uranium thorium, okay, by mass spectrometer. Okay. And then what we are having, that continents covers the area around the globe is almost 30%, and rest of the area of almost 70% has been covered by an ocean. Okay. And then sea level changes have occurred through time. Okay. That what we call the glacier fluctuations, and prominent linear features, okay, which exist on the Earth's surface. So, one is the circum-Pacific belt and the alpine Himalayan belt on the Earth. Okay. So, we are having this area, and then we are having the prominent feature of oceanic ridges, okay, or oceanic ridge system, which is covering almost 65,000 kilometers, which exists like this, okay, over here. So, it goes around the Earth, and then we are having that one. So, we have several prominent features, and another most important one, which we also know, is the highest, okay, area, that is the Everest, and the deepest part, okay, which we are having the Mariana Trench. Okay. So, to the highest location, or the on the Earth's surface. Okay. So, we are having the highest point on the Earth's surface is Mount Everest, almost like 8,800 kilometers, or sorry, meters high, and then we are having the lowest point, which is almost 11,000 meters, okay, deep, and that exists in the trench area in the Mariana Trench, which is known as Mariana Trench. Okay. So, it is located here, and then our Everest, of course, is in the Himalayan region. Okay. So, these are the facts which we are with the Earth, okay, within the Earth system. Okay, we are having. Then another one, if you look at, this is from Arizona, and if you see the Grand Canyon, okay, then at the base, the rocks which are seen are as old as 1.7 to 2 million years old, whereas at the top is almost like 250 million years old. So, it has a history of the deposition in this region. Okay. So, if you look at the geologist studies, or probably of course they have studied this. Okay. So, they can talk about that how they were deposited and when they were deposited, whether there was a period of non-deposition, and then whether there was some event which affected the areas in terms of the climate or in terms of the the tectonics. Okay. So, this is what we have, and then another picture here, this is a big crater, okay, and the crater is almost like 1.2 kilometers wide, and it says that about, this is also from the Arizona, it says about 50,000 years ago the explosive impact of a meteorite, okay, which was about like 3 lakh tons in the weight, okay, created this 1.2 kilometer wide crater, okay, and just in a few seconds. So, we have a lot and lot to know, and lot many surprising things which comes in front of us when we talk about the earth. Okay. Now, if we talk about the origin of earth in particular, and we look at the internal structure, what we see that we are having a different layers, it is not homogeneous. Of course, the internal structure of earth I will talk later, but just to talk here that we are having the inner core, then we are having the outer core. Inner core is massively hard, the outer core is liquid, then we are having mantle, and then we are having one another layer which is partially molten, is the asthenosphere, and then we are having a very thin crust, okay, which is made up of the continental and the oceanic crust. Okay. So, what happened initially was that initially the earth was cool with uniform composition. So, it right in the beginning it never had like very similar composition what we see now, okay, but it was an almost homogeneous uniform composition composed of silica, iron, magnesium and aluminum and oxygen. Okay. Now, repeated meteoritic impact in the past, okay. Now, we cannot have the meteoritic impact, there are reasons for that, okay, because it cannot enter into the atmosphere which is surrounding the earth. Okay. So, during in the initial stages, the meteoritic impact on the earth transferred the kinetic energy into heat energy, and this started heating up the earth, okay, and which the heat was also added up from the radioactive material like uranium, thorium and potassium which existed in the earth interior. Okay. So, later what happened was that because of the heat which was generated, the heavier particles, okay, the heavier material, that is iron and nickel, they started segregating in the center, and that is one of the reason why we are having the core which is comprised of iron and nickel, and the lighter ones like silica, magnesium and aluminum, they floated towards the surface. And this is one of the reason that why we see that crust is mostly made up of the lighter material which we call made up with the silica, magnesium and aluminum, and most of the rocks which are comprised of this material, whereas the deeper part of the interior of earth is with the heavier material. Okay. Now, we will move to and try to understand that what is the earth system, right, as a whole. Okay. So, if we look at the earth system, then we talk here about the internal and external processes, okay, which has produced different type of landforms, okay, and still the process is ongoing, the internal process and the external process which are responsible of they are responsible for shaping of the landscapes. Okay. So, we are having the like the internal, we are having the plate motions and all that, and then external. So, these are the internal one, and of course, this plate motions or the heat which has been generated in the interior of earth also generates the geothermal energy, or it is responsible for producing the geothermal energy also. Okay. So, plate motions are internal processes, whereas the external processes, for example, is the hydrological cycle. Okay. So, these are the two main processes which we see around us. Okay. Now, if you look at as I told, that is earth system. Okay. So, system concept, if you look at, we have three type. Okay, we have the either it is an isolated system, either we are looking at a closed system, or we are looking at totally an open system. So, let us look at and try to understand that what type of system we see, or the earth is. Okay, either earth is a closed system or it is an open system, and if it is an open system, why it is open, or it is an partially closed system. Let us look at those. Okay. So, the system concept, when comes, we can talk about the isolated one is the system in any portion of the universe that can be isolated from the rest of the universe, okay, from observing and measuring the changes. The simplest kind of understanding, or we can talk about for the of an isolated system is that boundaries completely prevent the exchange of either material or energy. So, it will not allow to exchange the material or energy, and it will have a very definite boundary, and that what we call as an isolated system. Okay. Then we are having another one, which is your closed system. Okay. But in the closed system, we will have some transfer of energy, that is the exchange of energy with its surrounding, but not the matter. Okay. So, it will just exchange the energy. So, keep in mind that this is, for example, we are looking at the sun here. So, we are having the radiations coming in, and we are having the radiations which are going out here. Okay. So, try to just understand. So, whether we should call this as a closed system or not, we will see ahead. Okay. But in short, the closed system is the system which exchange the energy with the surroundings, but not the matter. Okay. Thank you. We will continue in the next lecture after this.